Hello, class. Welcome to our lesson today, second part of section 7.2. And again, this is the ambiguous case, the case where you have two sides given and an angle given for the law of sines. So we're just going to review how to find some of those angles and make sure we're clear about what the expectations are, and then we'll solve a full triangle with finding the side lengths as well. Okay, for this question, it just says find the missing angles. So I set it up. Notice I have angle B and side length B. They go together here. I have angle and side length A that go together, but I don't know angle A yet. So I set it up. Sine of 113.72, because that's angle B over side length B, equals sine of A over, sine of angle A over side length A. I cross multiply, so I have this piece here, and then divide by the 243.8. When I get that, I should get around something around 0.711, and then do sine inverse. Remember to do the inverse feature. Make sure you're in degrees as long as the questions are dealing with degrees, which most triangle questions are in degree mode. I remember I should get two answers, so this is what we talked about the other day. I should get 45.4, that's one answer, that's in quadrant 1, and my second answer is 180 minus that, which would be 134.6. Well, you notice I already crossed that out, because if the first angle is 113 plus the 134 is already bigger than 180, so it's out. So there's only one set of solutions, one triangle possible in this scenario. And so then I can find angle C by taking 180 minus the 113.72, the given angle, minus the 45.4, and I get 20.88. Make sure you pay attention to what you're supposed to round to on these situations, and plug in what you need. If a question's in degrees, minutes, seconds, the answers need to be in degrees, minutes, seconds. That's more obvious on your homework because there's spots for those two things. A little bit more challenging if it's a test question, so things to keep in mind. The next one, I have angle C is 72.2 and side length C, which is 7.62. I have side length A, but no angle A, so I do the law of sine. So sine of 72.2 over 7.62 equals sine of A over side length A. I cross multiply, I divide out, I do the sine inverse. Sine inverse of 1.36, and that doesn't work, which means there's no solution, which is oftentimes what students hope for, because then you're done, okay, with any question. But that means that there's no possible way to draw any triangle that has those three components to it, and so there's no solution to that. But that will match up with what your calculator shows. Now, if you get that on every single question, you're probably plugging something into your calculator wrong. So that's something to keep in mind as well. The next one, obviously we've done one solution, we've done no solution, so you probably guess there's two solutions to this one, and you would be correct. I give you side length B and angle B right here. I give you side length A, so we got to find angle A. So sine of angle B over side length B equals sine of A over side length A. Cross multiply, divide out by the 697, and I get sine of A equals the 0.95 number. I do sine inverse, and so that would be 72.16 for A, or 180 minus that, which would be 107.84. And in this case, they both work. So to find angle B for the first one, I take 180 minus the given angle, minus the 72.16, and that finds me this angle that's missing. And then same thing, 180 minus this number that was given to me, minus the 107 number that I found by doing 180 minus the reference angle, and then angle B will work. That means it's the swivel idea. So it was like this, or it could have been like this. Okay, I don't know which one. So there's two possible answers for that situation. And so you'd have to write all of those pieces down to be successful on a homework question or a test question as you're looking at those types of law of sines scenarios. Okay, the next one is a solved triangle, so you have to work through and just solve everything. The most common mistake, which actually I kind of was making this mistake as we were going through, I was kind of on a roll and I just keep going, is the fact that this is degrees minutes. So I had started originally with my answer in degrees with decimal, and then I thought, oh, I got to go back and make sure they're all degrees minutes because it was in degrees minutes to start with. Remember, some questions may tell you to round to the nearest 10 minutes, excuse me. I just rounded the nearest minute just so we could see what the answers are. Obviously, you might have some leeway on some of those questions in terms of what the answer should be. This question gives you angle C and side length C, so that's my setup here on the left side, equals sine of angle A, which is unknown, divided by the 8.61. I do my cross multiplying. I get sine of A equals this multiplication of 8.16 times sine of 29 degrees 50 minutes, then divide by the 5.21. I do the inverse feature. I get 55.3. If I do 180 minus that, my secondary option will be 124.7. I make those into degrees minutes, okay, by using the DMS feature on my calculator. So don't forget to know how to do that to make you able to switch from degrees decimal to degrees minutes seconds. The problem is that both of these answers work. So if the first answer was 55 degrees 18 minutes, I take 180 minus the given angle minus this answer that I just found, and the B value, the B angle would be 94 degrees 52 minutes. I plug into the original information again, so use angle C and side length C, but now I use angle B and solve for side length B. I cross multiply, divide out. Remember, because you're finding a side length, you don't need to do any inverse feature because it's not sine of that side length, it's just the side length by itself. Sometimes students start saying, oh, there's no solution because I can't take sine inverse of that. Well, it's a side length and there was no sine in front of it to begin with. And then you get an answer of 10.44. Notice that this side length is bigger than the other two because that angle is an obtuse angle, so that makes sense in context of the question. The other A value I found was 124 degrees 42 minutes. I subtract those two things, the given and that answer, out from 180. I get 29 degrees 28 minutes. I set up the law of sines with C again, and I use that in order to find side length B. It's the exact same setup as the last slide, except instead of my obtuse angle that I had found, I got the smaller acute angle of 25 degrees 28 minutes. I cross multiply, I get a much smaller answer here of 4.50. And notice that angle is the smallest. A side length is the smallest, excuse me, because the angle is the smallest. Okay, so that B angle is the smallest of the three, so it makes sense that side length B would also be the smallest. Okay, overall, there's three scenarios for if there's two sides given an angle. First off, we need to know that there's a ratio between the two. That's why law of sines can be used. So you have to have like A and A, or B and B, or C and C. And then once you find the angle, remember you're doing the inverse feature to find the angle, but then always split it up into two problems. Have that angle and then 180 minus that angle, and then go through the problem twice, okay, to see if there's two sets of solutions, one set of solution. No solution is the easy one because your calculator will say, oh, I can't do this because I can't do the sine inverse of a number greater than 1. Okay, that's what will happen in those situations. Have a good day, everyone.